Good day, everybody, and welcome back to Precalculus. Today we're going to be doing Chapter 2, Section 2, and Chapter 2, Section 3, linear equations and rates of change all at the same time. Okay, so an equation is said to be linear if all exponents are 1, there's no variables in the denominator, no fraction, and there's no variables multiplied together. And if you satisfy those things, you have a linear equation. Okay, so let's take a look here at our first example. So we see we have no variables in the denominator, all exponents are 1, there's no variables multiplied together. So we know this is going to be a line. Okay, and if we do some quick math and just isolate our y, move some things around, we're going to get y is equal to 2/3 of an x minus 7/3. So one way of graphing this is simply by making an xy table and just graphing -2 to 2, plotting some points. Okay, if we plug in -2, so that'd be -4/3 minus 7/3 is -11/3, and you can just keep doing the math and plug in -1, you get -3, plug in 0, you get -7/3, plug in 1 and get -5/3, and plug in 2 and get -1. Okay, now some of those points might be kind of hard to draw, but we know we can draw -1, -3 very easily, and we can draw 2, -1 very easily, and it only takes 2 points to draw a straight line. There we go, we got our straight line. Okay, the next way we can draw a line is by not solving for y and just going by x and y intercepts. So if we think about the intercept method, x-intercept. At any x-intercept, that means the y is 0. Okay, so I'm trying my best to cover up the y is 0. So 4x has to be equal to y. That means x is equal to 9/4. Okay, so on your table, if x is 9/4, y is 0. Now let's cover up our x. Let's make our x 0. And if we make our x 0, that means 2y equals 9. So y equals 9/2. Now it's really easy to graph. So 9/4 is a little bit bigger than 2. 1/4 bigger than 2 to be exact. And 9/2 is a little bit bigger than 4. So 4.5 to be exact. There's your 2 points. It only takes 2 points to draw a straight line. So you're using a straight edge, and there you go. Okay, so now jumping down to slope. There's multiple ways to define slope. Okay, so the word way is rise over run. Rise over run. It can also be called delta y over delta x, sometimes read as change in y over change in x. Okay, the equation for slope, which you might remember from algebra 2, is y2 minus y1 all over x2 minus x1. The change in y over the change in x, just like we just had. Okay, and it's also denoted as m in our slope-intercept form, y equals mx plus b. Okay, so positive slopes go uphill, left to right, and negative slopes go downhill as you read them left to right. Okay, vertical lines have a slope that is undefined. If you think about it, there's no run. Okay, it's all rise, no run. Okay, so the equation is going to be x equals sum h with an x-intercept at h0. Horizontal lines have a slope of 0. They have a slope of 0. Think about it, it's all run. There's no rise. 0 over anything is always 0. So the equation is always going to be y equals some number with a y-intercept at 0, k. Parallel lines have the same slope. Therefore, the slope of line 1 is equal to the slope of line 2. the symbol for parallel. You may have seen this in a couple different ways, but two lines that are parallel to each other. Perpendicular lines have opposite reciprocal slopes. Therefore, the slope of line 1 times the slope of line 2 should give you -1. And that symbol is this upside down looking T-fin. Okay, so our first example here that we're going to do is we want to find out, are these the line between these 2 points and a line between these 2 points, are those 2 lines going to be parallel, perpendicular, or neither? Okay, so let's find the slope of this line first. Okay, so y2 minus y1, 2 minus 8 over x2 minus x1, -4 minus 4, which is -6 over -8. Negatives cancel out, give us a slope of 3/4. And now let's do our other one. So we have y2 minus y1. So we got 1/3 minus -5. Okay, well, -5 is 15/3. Okay, so I can have common denominators there. And then x2 minus x1 is going to be -1 minus 3. So let's see what we get here. So these are going to make a plus. We end up with 16/3 over -4. Well, when you divide fractions, 16/3, change the multiplication and flip the bottom one, so it'd be -1/4, which is -16/12, which is, I know I'm running out of space here, but -4/3. So because this one is -4/3 and this one is 3/4, those are opposite reciprocals of each other. Therefore, these 2 lines are perpendicular. Opposite reciprocals of each other. Okay, now let's talk about slope-intercept form. Specifically, y equals mx plus b, probably the one you're most familiar with. So the line has a y-intercept at b and a slope of m. And we can generate from solving the general form for y. The general form, which we just saw over here. Okay, general form, if you want to rewrite it out from here to here, solving for y. Okay, so we're being asked to write the equation, this general form equation, ax minus by plus by equals c, whatever, okay, in slope-intercept form, and identify the slope and y-intercept, and then we're going to graph it, okay. So for solving for it, I'm just going to move my 3 to the left side and my -12y to the right, and I'm going to divide everything by 12. Okay, so this is going to be 1/3 of an x plus 1/4 equals y. So I can see right now my slope is 1/3 and my y-intercept is 1/4. So if I go over here and draw my y-intercept at 1/4, it's kind of hard to see, but there it is. My slope, my rise is going to be 1, and my run is going to be 3. So I'm going to go up 1 over 3. Now I have my 2 points. I can make a straight line, and I can graph it accordingly. All right, let's keep rocking here. So the next equation we're being asked to find is find the equation of a line. We're going to put it in slope-intercept form, going through these 2 points. Okay, so the first thing we need to do is find a slope. Okay, so finding a slope, y2 minus y1, so 5/4 minus 1/2. So 5/4 minus, let's say minus 2/4. Be clever there, have common denominators. Okay, and then 1/2 minus 2, let's say 4/2. So that's going to end us up with 3/4 over negative 3 halves. Okay. Keep the top one the same when you divide fractions. Switch to multiplication, times it by the reciprocal. Our 3's are going to cancel out. Negative 2 over 4 is negative 1 half. So we know our equation is going to be y equals negative 1 half x, and then we have this b. Now all we got to do is pick one of these points. We know these points lie on this line. If we pick one of these points, we should be able to solve for b. I'm just going to choose the first one. So 1 half is equal to negative 1 half times 2 plus b. So 1 half is equal to negative 1 plus b. I'm going to add 1 and get b is 3 halves. So our final equation is negative 1 half x plus 3 halves. Final answer. Okay, the next two questions I'm actually going to have you guys do on your own, but I'm going to give you guys some tips and relate it back to the example we just did in example 3. So they're giving you the equation of a line here and asking you to find the equation of another line that is parallel to this line. So first you're going to have to solve for y to figure out what the slope of this line is going to be. Okay, so you're going to solve for y and you'll get y equals mx plus b. Okay, you'll be able to tell what the slope is, and the slope of your new line is going to have the same slope. Okay, so you're going to end up with y equals something x plus b. You're not going to know what b is until you plug this point right here in for x and y and solve for your new b, and that'll give you your new equation. It's going to be the exact same process down here. Okay, a different line that you're going to solve for y. You're going to see your slope, but then you're going to have to take that slope and make it the opposite reciprocal to find the slope of your new line before you plug in this point in for x and y and solve for your new b. So pause the video, give it a shot, rewind it, and listen to what I just said if you have to, but give it a shot and see if you can get these two on your own. Okay, the last form that we're going to talk about is point-slope form. And point-slope form is y minus y1 equal to m times x minus x1. Okay, so point-slope form is useful when you have a slope and you only have one point, x1, y1. Okay, you can use just that information to take this and put it in a slope-intercept form, which we're going to do here in a second. So we're being asked to find the equation of a line that has a slope of 1/2. Cool, we got m. And goes through the point 7, negative 2. So great, we have a point. So in point-slope form, this is going to look like y minus y1. So that's going to be plus 2 because y1 was negative 2. Is equal to the slope 1/2 times x minus x1, which is 7. So there's the equation of that line in point-slope form. So now converting it to slope-intercept form is simply solving it for y. So the first thing I'm going to do is just distribute my x, or my 1/2 times x, and my 1/2 times 7. And now I'm going to subtract my 2. I'm going to be clever and say that I know that 2 is equal to 4 over 2. So I'm going to be subtracting 4 over 2 to the other side. So my 1/2 x is going to stay the same. This is going to be minus 11 halves. Okay, now taking this and putting it in general form, remember that general form is ax plus by equal to c. I can easily take this and make it into this. First things first, I just have to distribute my 1/2 again. So I got 1/2 x minus 7 halves. Next, I'm going to get my x's and y's on the same side. So I'm just going to subtract my y over. I got 1/2 x minus y. I'm going to add my 7 halves over here to this left side, which we know is 4/2. We just talked about it over here. And 7/2 plus 4/2 is 11/2. And typically with general form, we don't use fractions. So I'm going to multiply everything by 2. Okay, so 11 is equal to x minus 2y. And there's your general form equation. Okay. Make sure you bring questions to class. Make sure you've tried all those examples that I had you do on your own, and I look forward to helping you.